Oh, we have mics here. Yeah.
Hello?
All right. You have a treat in store for you. I have been super stoked about this panel since meeting the panelists a few days ago. Interoperability is a huge, important, fascinating topic for obvious reasons. So yeah, I'm really excited to dig in. So we have Wenwei from Polymer Labs, Sergey from Axelar, John from Hyperlane, and Carl from Shima Capital. Is that right? Shima Capital? Yep. So let's obviously kick off with intros. Tell us who you are, what you and your organization do, and if you don't mind, just say one additional word about how you think about interoperability or why it matters. Wenwei, do you want to kick off?
Test. Yeah, I'm Wenwei. Before joining Polymer, I've been doing academic research and in the industry, working on life science and distributed database systems. And what excites me at Polymer is our mission to bring interoperability to all the blockchains to everyone. And of course, we can delve into that later, but for now, I can say that I see the only way to interoperability is open standard inter-blockchain communication protocol, which we are currently building. And on top of that, with zero knowledge proof and setting the light clients for the supported chains. And that is our thesis on this mission.
Hey guys. Hello.
Oh, you gotta flip that on.
Yeah, make sure it's on.
Test.
There you go.
Here we go. Hey, Sergey, co-founder of Axelar. Briefly, my background, technical, distributed systems, cryptography, was a faculty at University of Waterloo, helped to design Algorand and take that to the market. And then afterwards, trying to see the blockchain space, understand what are the big problems that need to be solved, and the problem of cross-chain communication, is, I think, a fundamental problem that needs to be solved, and that's what we're, working on Axelar. To me, it's a tool to get to the destination, and the destination is to allow users to interact with any asset, any application, any chain with one click. So that's what we're working on.
Hey, John, I'm one of the founders at Hyperlane, another interoperability protocol. I'll tell you all about it today. Before we started this, I spent the last few years at Galaxy. If you're familiar with Mike Novogratz's firm, I ran the investment team there with a wonderful partner, Michael Jordan. Some of you may have heard of him, met him. Been in crypto for about 5 years. Before that was at Morgan Stanley as a bond trader. Strange place to be if you hate banks, but I ended up there. It was nice, didn't mind it. When it comes to interoperability, I feel very lucky right now to be here with Sergey, because Sergey is much more eloquent and articulate when it comes to explaining the same idea. But it does come down to this point of we want to reduce the levels of infrastructure interactions that you have to do as a user when you're working with decentralized applications. Right now, all of us spend a lot of time interacting with infrastructure. We don't think about it, or maybe when we know it, we don't mind it, because it kind of has made us money the last few years, and that's been great. But that's an untenable situation, and that's, I think, the ultimate vision for what all of us are working on.
Cool, thank you. Hey everyone, Carl from Shima Capital, CTO investment partner. Prior to venture capital, I worked at JPL NASA as a software engineer on their flight systems for space missions. And I'm a huge fan of interoperability related projects, because the way I look at this is that L1s, L2s are the muscles, right? Everyone likes to have, train their muscles because it looks great. Helps you with your strength, but interoperability is the ligaments and tendons of your body, right? Without those, you're not able to utilize your muscles because you're not able to move the liquidity around and so forth. So happy to be here and excited for this panel.
Yeah, me too. That is an awesome metaphor. I might borrow that. Thank you. Very exciting. I'm Lane. I'm building a layer 1 blockchain called Space Mesh. And I guess as a core developer and protocol designer, I think a lot about interoperability, specifically how I can design my protocol in such a way that makes interoperability easier. So there's a lot of kind of deep implications on the protocol from kind of the VM layer and game theory and things like this that I hope we can dig into. So we could kind of approach interoperability in two directions. We can kind of go bottoms up and start with that deep infrastructure, or we could kind of start top down. I kind of want to start from the application side. I just think it's kind of more approachable and interesting to frame things in that way. So what I'd love to ask you guys, just open question, what applications does interoperability enable? And like maybe what's the one application that you're the most excited about? Anyone want to jump in? John?
So I think if you've been in crypto long enough, it's hard to miss that stablecoins really have been the most pervasive, probably most successful form of decentralized application. Probably everyone here who uses crypto has experienced with them. I transferred some this morning, transferred some last week. Now, they are fairly limited to one substrate right now, to one environment. And then we have these like less than ideal, less than secure modes of accessing them. And what we're working to change here is enabling this concept of the interchain stablecoin, right? Something that can natively move between these networks in a way that you as the mover of money don't have to think about like the pipes, right? Like I bought something on Amazon and I don't think about how the money got to Amazon, it just did. But when I have to pay, you know, we have a really nice guy working for us who really likes getting paid in USDT on Tron. He only wants it on Tron. And it's a pain in the ass to get there, right? It's a hassle for us, right? It takes 45 minutes every week, but you got to do it. And so an interchain stablecoin immediately solves that. Once you have something like that, either to enable it or kind of as a layer beneath it, you can imagine an interchain maker-like system, right? Where you can accept collateral from anywhere and then utilize it in other places. And so that to me is like the most imminent thing that like people would use, like they'd use it yesterday if it was there.
One of the earlier panelists this morning said something about, it was a great metaphor comparison, like when you use Venmo, right, you don't think of your Venmo dollars as Venmo dollars, you don't think of your PayPal dollars as PayPal dollars, or your Bank of America dollars as Bank of America dollars, they're just dollars. So like that's the goal, that's what we should be working towards.
Exactly, right, like I don't think about the Bezos bucks that exist on Amazon, or right, like, but we do in crypto, we have to because of the nature of the systems, and these are all systems that are trying to change that nature.
Yeah, so I think to me, probably, I think stablecoins are awesome, and yeah, we should abstract them away. I think exchanges is still a pretty big unsolved use case, right? So if you think about it, why we had, FTXs of the world is because you could not have built a decentralized, exchange or automated market maker that transparently swaps across multiple platforms 3 years ago, right? 2 years ago, period. You could not have built it. And so as a result, we ended up with these layers of, centralization built on top of all these chains that provided better UX, that provided better liquidity properties. So to me, I think still, a very important problem to solve is to be able to at least replicate one of the biggest use cases as well in the crypto, which is just basic asset swaps across different platforms, across different tokens with the same level of UX, with the same level of liquidity as you can have on a centralized platform that's built on top of it. So I think that would be awesome to see.
Yeah, super good point here is that interoperability is a means to an end, right? It's not the end. So, and it also shows how early we are because remember DeFi summer, everyone's talking about DeFi. Hey, this project is super hot. It has high APY and so forth. And now there's less people talking about DeFi. And generally people feel that, hey, DeFi is not a hot topic, but that's not true, right? What it is DeFi is going from the application layer to the infrastructure layer, right? If you think about this, metaverse, NFT, gaming, they all need DeFi. Without DeFi, you're not able to trade, you're not able to perform value of exchange and so forth. Same applies with interoperability, right? It's not about what application need or should use interoperability. It's more about what can we not achieve today can be enabled by interoperability, right? For example, there's not really a dominant true cross-chain application today. There are minor fixes here and there, bridging capability. That's due to the immaturity of the ecosystem. So as it evolves, I believe that maybe 2-3 years down the road, XLR, Hyperlink become more mature. We don't talk about them. That's because they're everywhere, right? You build an application, you don't have to think about, hey, do I use Hyperlane or XLR? There are a significant amount of stacks below that to kind of decide for you, so you're able to build your application in a more seamless way.
In our mind, I think the previous panels have touched on very interesting and great points on modular blockchains and how to enable mass adoption. To us, I think the interoperability is a prerequisite. Instead of thinking about the application layer and what's the interop layer bring us is a fundamental seamless user experience for both developers and the end users. Like John has touched upon, if you're using some traditional Web2 services, you're not thinking about how these different nodes, backends, your apps are talking to each other. We just assume and take for granted they will be communicating through this open standard protocol, like the TCP/IP. But here we believe a similarly inter-blockchain protocol that is open to everybody and maintained and contributed by the community would be the ultimate solution.
Yeah, thank you for sharing your perspectives. I want to agree with what Carl said a moment ago about that there aren't any truly interoperable applications. I mean, it is possible going, through certain hoops and using bridges and things like that, and there are Uniswap or other protocols that have been deployed on many chains. But so that's one side of the story. The other side is that have come a long way, and interoperability is way better than it was, certainly when I started in the space a few years ago. IBC and other standards have helped a lot with that. What's missing? What do we need to achieve the beautiful vision that Wenwei was just describing about, a future where the user experience, the developer experience is way better? Is it standards or is it other things?
I mean, yeah, so maybe just to actually take a slight step back, right? Why we are even talking about interoperability. Because I think in some sense, the blockchain industry evolves in reverse with how, let's say traditional networking has been evolving, right? And I think I recently wrote a blog post where people talk about communication on the intranet 20 years before a single application used any of it. And I think in blockchain, we ended up with a very reverse position where, a lot of layer ones competed with one another. They're like, we don't need communication. And then, everybody realized, you actually need communication, so let's figure it out where we take it from, right? So the reason we're talking about it is that the demand kind of pulls the technology, and technology has been built in parallel, right? Interoperability on itself is not a single protocol. It's not a protocol. It's a stack that has to be built that includes everything from transport layer, routing layers, relay layers, SDKs, kind of data layers, and things like that to enable, at the end of the day, the experiences that we talk about it. And so while I think today there's a lot of focus on the basic core pipes and what security of them should be, how does A talk to B, is it light line, ZK, and things like that, there's actually, I think 3 or 4 layers that have to be built in parallel to make the whole user experience smooth at the end of the day. And I think a lot of people, focus on the connectivity still piece and the security of it, which is fine. We should talk about it.
We will. It's on the agenda.
But yeah, I think the stack is, like I said, it's the routing layer, the validation layer, it's the message semantics, it's the SDKs and APIs, and the user experience layer that has to be built.
So basically it's everything. We have a lot of work to do.
Pretty much the whole dev experience has to be reshaped in the multi-chain world.
Yeah, in the same vein as modular blockchain, we believe that modularity is actually the fundamentals to separation of concerns. Of course, it is a full stack from the specifications, which is abstract, and also the concrete implementations. But I think the seamless user experience is only possible when the developers and the users can do freely with open standard and assuming everybody is playing a fair game. But of course, that will come with different security guarantees, which we can talk about later.
Totally. To augment some of these points, let's try this again. You end up being to augment what was said here earlier. Think about yourselves as using these applications right now, and think about we're in a world where unless you're in Cosmos land interfacing with something like Kepler, you're probably using a couple chains, and the swaps between the actual process of going in between each one, it's fairly cumbersome, right? Like you'll pull up whatever your wallet is, and now you have to point the RPC to a different thing, and now there's like a button that some networks might ask, but it is a lot more relative to anything else you do on the web. So like who's working on that? Who is changing that bit of connectivity? Now imagine this is our current state. Your run-of-the-mill ETH head likes to think that there's going to be 1,000 rollups and they're all going to come out of this ETH hub. Well, so what do I do then? How do I navigate that? Am I going to have to keep track of what am I doing and where and how that's all working? That seems considerably worse, right? So how do we get there? So in many ways, right, like we have a modular design, and so very much big proponents of it. But if this work isn't done, that vision that we talk about, like it's just not going to materialize itself. It's going to be an actually considerably worse experience, and that's why when Sergey says like it's not just the connectivity, it's this full stack of things. The entire developer experience has to change first, so that you can create an actually manageable user experience. Because we're not going to be walking around like this, the cyberspace holding up like 1,000 record books of like, okay, so I have this balance currently on roll-up C137, and then I have like these balances on all the other ones, because that's kind of where you are right now, and it is very gross for anyone who has many balances on a number of chains, as I'm sure many of you do.
You need a spreadsheet to manage blockchains.
I mean, the de facto operating model for some of the bridges, which is a subset of interoperability, is you have liquidity on both ends, right? And that's kind of normal for the entire community. But if you actually think about this is absolute insanity. You have to lock up liquidity on one end, on both ends, and then you can do interoperability, right? So this just goes to show like the lack of the maturity of infrastructure, right? Can you imagine like, bridging over millions of dollars of ETH? You will have to have liquidity on both ends. However, that is changing with generic messaging and so forth, right? But it just goes to show how early it is that we don't have a comprehensive infrastructure, and the capital is extremely inefficient. So, yeah.
I don't know. Hopefully, I have a loud voice. It's fine. I'll make it work with this mic. No, this point about capital efficiency is really interesting. I want to maybe just take a second and double click on it. Any of you guys have thoughts on how we can do better? Because to Carl's point, like the bridges are very capital inefficient today. It's definitely an area we could improve.
I mean, to add on with what I just said, the bridges and these interoperability protocols are doing more than just cross-messaging and so forth, right? Because if you think about this, my opinion is, for example, Circle is coming out with something new, CCTP, which allows you to burn the tokens on one side and then mint the token on the other side. Well, all you need is really the messaging layer, right? So I think we're moving towards the right direction, but I would argue 95 or 90% of tokens are still in the same old fashion where it requires you to lock up liquidity. So yeah.
Yeah, so the argument on that, that's exactly what I was going to say. The change has to come from the asset issuer. And you're seeing Circle as spearheading this as an example that we can all draw from, right? Axelar is working with CCTP, Hyperlane's working with CCTP, because this is just like a native way to do it. Now, Circle is an issuer of enough size and enough magnitude that they were just going to always do this themselves. But actually, like if you take some time to investigate, you'd find that I'd say the premier interoperability stacks, whether it's Axelar, Hyperlane, you already have this capability of minting, in our parlance, what we call an interchain asset. An interchain asset is one that does not have a concept of like the canonical state, from which you'd wrap it and put it somewhere else. Right? It is designed to, your transfer to has a chain field. And so now you're going to burn it whenever you move it from chain A, and you're going to mint it on chain B. And so, but you have to make that asset that way from the outset. And so either you get a very recognizable issuer like Circle doing it to their own asset, or you get newer kind of upstart asset issuers that say, you know what, I'm starting like this from day one. Because unfortunately, like the way blockchains are designed, there is no easy way around it, right? Like there's no free lunch in this case. The asset does need to be physically present. These are bearer asset systems. And so you either have to replicate it with wrapping, or you have to just make it go there through these systems.
Yeah, I mean, I think one thing though is that, ACID is an application built on top of these protocols, and so yes, you have to have a different way of deploying the ACID, to have better liquidity. There's a different way to also what I call like build applications where the ACID doesn't have to move, right? So kind of right now, we are in this world where we're shuffling the assets ourselves, right? Like we're routing them and kind of very manual process. You can build an application that's what I call like interchain native, where the asset doesn't have to move, it could stay on the chains where it has the deepest liquidity, and information about its like lock and unlock features can be communicated to other contracts and other chains to perform an action, right? So for instance, if you want to take a loan, you have an asset on one chain, you want to take a loan against it in an asset on a different chain, you don't actually have to move the asset, okay? You can lock it on one chain, still keep it there with the deepest liquidity, send a message to another chain that authorizes this loan to be issued to the user. So I think like Prime Protocols does something like this. So I think the analogy that I make is that, you can kind of move the asset to where the programs are, or you can move the program or part of it to where the assets are, right? And I think the second way, in the long term, or a combination of them, is like how you solve all these liquidity and like slippage issues.
Yeah, I think this also circles back to the previous question, regarding the token bridge. What is possible? Was unattainable before the interoperability it becoming the mainstream? I think one of the application for cross-chain or token bridge is, Catalyst, which is built on top of our Polymer stack. It enables a native multi-chain token swap without having to lock, unlock, or minting artificial, intermediary coins. So it uses passing the message on one chain and gets verified through the consensus layer, and you don't have to trust any intermediate relayer, so that it has the same guarantee as both underlying consensus engines. Yeah, this is a novel application. Check it out, Catalyst. Sorry for shilling here.
It's okay, shilling is allowed on this panel anyway. Yeah, so this is this notion of native interoperable or native cross-chain assets and applications. I think it's a perfect segue into something else that I wanted to talk about, which is just zooming out and looking at how the overall landscape has changed over the past few years. I'm a crypto boomer, so I'm showing my crypto age here, but when I got started in this space, there were no rollups, there were no layer 2s, it was all kind of like layer 1s, and bridges were in their infancy at that point in time. But the landscape has obviously changed dramatically, and the concept of like modularity has come up here a couple times. So that's one good example of this. Obviously, like rollups are another good example here. So I guess the question is, does it still make sense to kind of think about the overall landscape as individual chains, as L1s versus L2s? We have new notions now like L2s bridging to other L2s, so kind of skipping the L1 entirely. I mean, a lot of this stuff is very experimental, but how do you guys think about this changing landscape, and how is it impacting your various projects?
To your question directly, I don't think it makes sense the way we think of L1s, L2s right now is like the layer 1, it does these certain things, and then you can have output some functions over to layer 2. I think the layer thinking still makes sense, but what do we do in these layers might not make the most sense as it is right now. Whereas we think more on like where they're going to be hubs of state, like the place where the end state gets written from, like what is the thing you're drawing some security guarantees from. So we see a world where you're going to have something like Ethereum as a major hub. Something might materialize in the IBC ecosystem as a major hub. Certainly they wanted the Cosmos, like Atom and the hub to be the hub. It has not materialized that way just yet, but you can see that happening. You can see Celestia being its own hub. Fuel, maybe that becoming its own hub. And then things emanating from these hubs and different layers built on top of them. But right now, with something like Axar, something like Hyperlane, you could actually use Avalanche as a totally performant layer 2 for Ethereum. but like that language doesn't let you think about it like that, because it's like, well, they're doing the same thing, they're competing on the same stuff. Like, are they? I don't know that they are. So we don't think it makes sense.
So I think from my perspective, it's important to understand why we're seeing this trend shifting towards more modular blockchains and everything else. And in some sense, I think of it as the only way to survive, period. So I think if you think about it, the world started with the Big Bang as one of the theories, if you want to believe, very synchronous event. We ended up with a very asynchronous world as we scale. And the same thing, I would say, kind of been happening in the blockchain space. We started with one or two chains. That was the Big Bang event. But to scale, to keep on making progress, to make sure every application can have the scalability, latency, and fee properties that it needs, you have to have resource isolation between stacks. Okay, like that's a very technical concept. Like you have to isolate resources if you want to provide reliable user experience to your users at a scale of millions or hundreds of millions down the line. And so we are going to be living in a world with many layers, modular, layer ones, layer twos, whatever you want to call them. And it's an asynchronous world. And so we just have to learn how to program in this world. And I think that's what we're doing to make sure that even in the asynchronous world, you can still have interactions as simple as they are all, in the synchronous world in some sense. And so I think that's the general trend. Like it's going to continue happening. And like I said, it's the only way to survive.
Yeah, I totally agree. Just removing most of the stuff out of the picture, right? So if you just look at it from a software reliability perspective, it makes a lot of sense just so that you have multiple layers and become modular. No one would fly an aircraft if they tell you 20% of the chance it's going to fall out of the sky, right? No one will
80% chance you'll be okay.
Yeah, right. So, why are these flight software so reliable? Well, because it's modular and they have redundancies, right? So taking that, because there's only two ways people care about your software. It's one way is if it's misused, you lose life, or the second way is you lose money, right? That's my principle. So blockchain happens to fall into the second category. So if you think about this is, as these ecosystems become more modular, you will be able to have multiple redundancies at the same level, right? So for example, if you need a data availability layer, or if one doesn't work, you can alternatively go to the other. So if the one fails, the entire system is not impacted, right? So it's very primitive software engineering practices that will eventually get us to that stage.
Yeah, totally agree. I think modularity and interoperability, kind of like two sides of the coin, cannot live without the other. And modularity also relates heavily to the underlying security mechanism guarantees. If you think about interoperability, basically, you're trying to move data from one chain to another. But what is the trust model? I think there is a spectrum how this mechanism of delivery can be trusted. First, you can trust a single party, like using a centralized exchange, like Coinbase, or you can trust multi-parties, and you can trust your online verification, like a multi-sig and multi-validators, or you can trust underlying consensus engine, which is, I think, it's the most reliable. And to the other extreme is you only trust the code. Obviously, that doesn't mean the previous levels you don't need to trust the code. Even the single-party verification, you still need to be sure that code is correctly implemented.
I have a hat that says "In code we trust" that I'm not wearing today, unfortunately, but as a hacker, it's one of my favorite messages. I feel like we're dancing around security, which of course is something that came up already today and that we wanted to talk about, and I think you can't talk about bridges and interop without talking about security. And Wenwei, I think you framed it very well by talking about the different trust models. How do you guys think about security in the context of your project, and how are those trust models evolving?
Yeah, basically, by breaking down our stack into modular layers, we basically assume every component is an attack vector. So from the source chain to destination chain to any intermediaries, we think everything can go wrong, but there's always trade-off, right? You can either do the transaction or not. And for our technology built on top of ZK-IBC, so we have the flexibility, and in the meantime, with the security guarantee, same as the underlying consensus engine. So for example, Ethereum. There are different thresholds you can set to the developers, what kind of the risk tolerance you want to have. You want to optimize for low latency, or you want optimize for finality. And we can create a different abstraction on top of that. So as a developer, you can freely choose your tolerance, and then the data just flow with the underlying trust guarantee.
I mean, from my perspective, we believe in security achieved through decentralization, right? Fundamentally, the protocols that are decentralized, they have diverse deployment stacks, they have diverse deployments, validators independently, kind of securing their code bases, deploying in very different environments, and so that leads to practical, better security at the end of the day, right? So that's what we're working towards. Kind of how individual kind of connections can be instantiated. I think you can have a spectrum, like we talked about. You can have centralized instantiation. You can have kind of decentralized external verification. You can have ZK or anything else. I think those pieces are just going to continue evolving over the time. But at the end of the day, the security of the protocol has to be decentralized and powered by kind of open permissionless technology.
Totally want to echo what these fine gentlemen said to begin with.
Did you guys plan this ahead of time?
No, you know what?
Not tell us. Or we have colluding validators on the panel here.
What there was there's just a good alignment of design between what the three things here are doing, right? This just that so happened that way, whoever is putting the panel together, nice job.
Well done.
Yeah, so it makes for like a smooth flowing conversation in that sense versus like, no one here has to convince you that they believe that like their guardian design is just like impenetrable because they got like the best people in the room, right? Like a different panel composition, you might have to have that. Not today. Certainly decentralization is important. I was really glad that Carl mentioned planes earlier, right? Like the aerospace industry is probably like the best one to draw from because the stakes are so high. So, you have 2 decades of like software engineering where people like they worked at these big tech companies and then they sometimes come into crypto and their notion of the stakes is just like totally whack because think of, let's say, there's many of them we can name because 5 of the 5 largest incidents in crypto are all related to our category. So pick any one of them. And those mistakes are often like, some of them are general security errors like, hey, there was a not properly secured multisig and some poor guy opened up a job offer, PDF, and the thing goes to shit. But some of them are just genuine like operations issues where you push an upgrade and you just make a mistake. Well, like you make a mistake at Google and like my YouTube video doesn't load. You make a mistake at Amazon and some guy is like stuck at checkout. You make a mistake in crypto and you're out 9 figures. And like the stakes are just totally different, right? The planes are falling from the sky. And so you just have to have like different principles in how you build things. Like build them, this thing can break. Okay, so if the plane is going to fall from the sky, like how do you prevent that? If the plane is going to get shot at, how do you prevent that? And those are the principles you have to bring into when you're building smart contracts, when you're building crypto systems, because we live in the most adversarial like space that software's ever seen. There's never been a more adversarial space. And if you don't build that way, like, I don't know what to tell you, right? Yeah, like it's coming.
I think you are our aerospace expert on this panel, so you can correct me if I'm wrong here, but like the way that design works in a space like aerospace is you don't assume that what you're building is not going to fail. You assume it will fail in many different ways, and you design using defense in depth, right?
Yeah. Something surprised me last year when I was talking to various recruiters. I asked them, what type of engineers do you usually hire that will eventually be performant, right? And it turned out, I was thinking maybe, and I was ashamed of myself for not getting this, was maybe guys from Amazon, Google, right? But that was not true. It turned out aerospace software engineers were the best engineers when it comes to layer 1 engineering. And it makes sense, right? Because it's not so much about your technical skills, it's about the mindset, right? How you're architecting your software and what you're focusing on, right? Example was, when I was in my early 20s, I had a huge ego, right? I was working in aerospace, I looked at the code, and there was one library, it was some floating point arithmetic library that Northrop Grumman developed, and I thought it was shitty. So I went to the senior software engineer. I was like, why don't we just use open source library, right? And I was laughed out the door because, hey, you have to write everything from the ground up if you want to make sure that suits your needs, right? Because they were writing a particular piece of software that was just for that CPU, and they had to make sure they covered all the overflowing or underflowing problem, because if it flips, it triggers the GPS and your airplane does a 180 degree, right? Which has happened before. Now, tying this back to blockchain really is, I think it's so early on that the level of rigor is not there, right? So if you think about the hacks, right, most of those are not high-level, consensus-level hacks where they've social engineered the validators and they colluded and they took down the not the website, the network, right? Most of these are some low-level engineer push the code without integration tests, without a system-level test, and boom, it gets hacked, right? So,
I'm laughing here as you mentioned floating point code, because as a core developer, this is a huge issue for us. I mean, we won't go too deep down that rabbit hole, but it's a good example of like floating point works differently on different architectures. So like there's a reason that you have these long 19-digit representations of balances in Ethereum. Ethereum doesn't use floating point in the core protocol because it causes issues. So that's a great example of the kind of things we need to look out for. And yeah, it's I don't want to call it a solved problem, but there are best practices that we should be adopting from spaces like aerospace.
right.
I mean, it just comes down to the failure modes are fucking catastrophic. Sorry for my language. They're terrible, right? It's the equivalent of the plane falling down from the sky, the Challenger blowing up, the Columbia blowing up on its way back down. Like, that's what it is. And it's not the
We should think about it this way. We should be, as engineers, yeah.
Yeah, I mean, like, think, you push an upgrade and you're like, great, my user is going to do this new thing. That's awesome. And then, like, 2 months later, your user's out. $200 million. But you shipped real fast. Like
Move fast and break things, right?
Like,
Move fast and lose money.
yeah, that's the
Or
thing.
lose lives.
Crypto in one sentence.
It's just like people are used to. Oh, I know. I ran this A/B test. We used to do this all the time at Facebook, and then those people didn't like it. They liked a little bit less. And they're like, here, those people are out 9 figures, sometimes 10 figures. Like, great. Those two are not the same.
I mean, I have a proposal. So, I think like an aerospace engineer, right? They always tell you like, you have to build the code as like your family's traveling on this plane tomorrow, right? And like, you make a mistake, somebody could die. And so I think, as we're working on this protocol, right? Like, maybe you should put like your family pension funds, right, on your interop.
There's a tradition I learned about among engineers in Canada. These are like structural engineers, civil engineers, where upon graduation, they're given a ring, a metal ring, and that metal ring is forged from a bridge that collapsed or a building that fell apart or something like this. And it's just a reminder of the enormous responsibility you have upon your shoulders as an engineer building critical infrastructure. I think we need some version of that in crypto.
Yeah, that's what good point. That's why we think the open standard protocol that can be adopted by everyone and contributed by everyone is crucial. It must go through this strictest guarantee and scrutiny by the whole community, and everyone can contribute to this, so that as long as everybody follows the same standard protocol, all the components are interchangeable. Like if you order a Uber car, it doesn't matter you're on iOS or Android, right?
So I think just to say that I think unfortunately, I don't think we're in a position that we can standardize these things because the layer ones are so different, okay? And so in the interoperability often comes down to the validation layer, right? And the validation layer so far cannot be the same because every layer one has its own like rules, finality, and so on and so forth. So while I do think we can standardize certain layers, like message semantics, IBC or whatever not, right? Like how applications talk to one another, I think underneath it, I don't think we're just yet in the position where we can say what the standard should be.
Yeah, I think a better way to think about this is potentially, and this is definitely controversial, is instead of like open standards for everyone, perhaps it's the methodology in which we use to verify these systems should be standardized. For example, Circuit K, Halborn, whatever, right? When they look at a layer one, these are the things they must verify, and they must use the same methodology to verify these things, because today they're really doing amazing work, right? Because sometimes I look at these reports, I was like, you guys must have really damn good software engineers on your team, because you're looking for things that it's so convoluted, and you're able to find out that
if this part's operated this way, that part operated that way, then it would trigger this condition, right? But I think it also makes me feel very shitty because there is no methodical approach to this, right? This good software engineer today might have a fight with his wife, and he won't be able to look at the things the same way, right? So,
Yeah, that's why, you know, we at Polymer are working hard to, we know this is not an easy problem to solve. Yes, that's why we try to extend the core IBC protocol to a more broader community network of chains like Ethereum. That's our main target chain to support. That is to say, you know, we do the hard work for the community, and then the community can contribute back to, you know, implementing more light clients so that every new chain in the space can be supported through a standard protocol. We believe this is the only way to, you know, universal interoperability to everyone.
All right, we're almost out of time. I thought we could spice things up a tiny little bit here in the end by talking about, what was it you said, John? You said 5 of the last 5 big issues have been, you know, bridges, interop, and stuff. So, like, what is your favorite bridge hack or interop failure in the past year or two, and why? Go ahead.
mine's really dumb. It's not even interoperability related, but there's this tool where you can generate vanity addresses, right? It's called Profanity, I believe. And I'm of Chinese heritage, so I used the tool. I generated tens of addresses that leading with like 10 8s, right? So I thought it was super interesting. But in the back of my mind, coming from aerospace, I was like, what if this tool has a vulnerability, right? And it turned out to be true because I think the problem was the random number that they were using to generate these addresses just weren't diverse enough, right? If my memory serves me right. And this goes to this is a really good point, right? So if you're using external libraries, like for example, no offense to the JavaScript developers, the npm package manager, that thing is cancerous, right? Like you have no clue, you have no visibility, what is the plugin, right? You know it works, and it always works. You can multiply a string by an integer, it still works, but it just doesn't make me feel good, right? However, that tool was really hacked, right? There was a lot of money lost. I think it was a couple $1 million. And that was my favorite because it's so simple. It just teaches a lesson. Be careful what type of tools you're using, right? Beyond your operational security.
So for me, this is not to throw shade at them, but there was an optimistic protocol, optimistic interoperability protocol that had a failure. It was a software failure. And this was one of my personal favorite because the whole point, as I view it, of the optimistic model is to have a certain amount of time and the ability to then examine transactions and then shut the thing down if you need to. And so we had a hack, the first of its kind, that lasted many hours, had about a 4-hour window where people were withdrawing funds from this protocol, which is very unusual, right? Usually the attacker just comes in, swoops, and this now the heist is on. This was kind of like looting, right? The doors were open and people were just running into the store and just grabbing stuff. And I personally view it as a failure of the optimistic model. So I have a massive fight over this with the folks on my team who are more technically minded, and they're like, no, it was a software bug. The model didn't fail. And I'm like, you're like the people who say communism was never really tried, right? Like, no, it was tried. They had 4 hours to shut the thing down, and they didn't. The optimistic model in this case failed. It's still a good one to try, but it failed. So that's my favorite.
So I think I really like the point, which is the complexity of those implementations. I think was the result that needed to be there for that model, right? But I think besides it, I think my favorite one that frankly didn't end up being a hack, but I think probably many of you know, but that was the bug in IBC actually last year that was discovered, right? That just shows that no protocol is immune to bugs or anything else, and you have to deal with it.
That code had been there for a while, if I remember correctly.
Yep. And so. We support IBC at the consensus layer, so we were affected as well. But I think the shout out goes to, like Informal, like Ethan, and the rest of the teams, and Zaki that kind of helped orchestrate and like prevent that. So it was like 2 days of, a lot of teams not sleeping and messaging each other and like doing upgrades and, and things like that. Nothing happened, I think, from at least what I understand at the end of the day. But I think it just shows the complexity that, security model for kind of individual connections is not the end, still complex. You have attack vectors. And this also shows operationally kind of what you have to have in place to actually deal with bugs. And I think we've seen bugs at the consensus layers, right? We've seen bugs in the bridges, and I think I hope the industry actually standardizes a little bit more of these processes as well as we continue building. As
much as we love to do a postmortem analysis, actually, I have none of the favorite attacks because, and behind every attack, there's real people, not only the addresses. So here, but there's a, fun one because our name similarities, a poly network attack, our investors came to us, are you sure you don't want to change your names? We're sure, yeah. We like the name Polymer Networks as it's the connected tissues to all the, inter-blockchain communications. Yeah, so we stick with the name.
It's a good name. You should keep it.
Yeah.
All right, I think we're out of time. Do you guys want to each just quickly tell folks here how they can follow you guys on social media or contribute to your projects? Carl, do you want to kick off?
First name, last name, Carl Hua, Twitter, Telegram, however you want to do it.
You can follow us on hyperlane_XYZ on Twitter. You can join our Discord. It's very active with developer discussions. We like to have fun there. And if you want to follow me, I'm the Pale Nimbus on Twitter. You'll see like the tinfoil hatted dick butt.
Sorry, can I say one more thing? We are hiring for a high caliber investment analyst that are deep into DeFi and infrastructure. So
we're hiring too. Everyone here is hiring.
Axel.network website, go to @AxelCore Twitter handle. You'll be able to find everything from there, including the job posts.
Polymer DAO, polymerlabs.org. And if you want to follow me personally or offline, we can chat more about interoperability and IBC, ZK, and everything. You can follow me on Winway, my first name _0x, and also we're hiring ZK and database engineers.
I'm L. Redig on Twitter. My DMs are open. Always happy to nerd out about Interop and other stuff. Thank you guys so much. This was a lot of fun.
Thank you, Lane.
Okay, we're going to jump right into the next panel. This one is on the blue ocean of Web3 data and AI. It will be moderated by our lovely head of conference, Katrina. She needs no introduction. And looking forward to introducing the rest of the panelists as well. Okay, I'll pass it to you. Of course.